In this video, I'll be showing how to find missing angles within a right triangle using sine theta, how to find missing side lengths using the sine ratio, and how to find the side ratio of an indicated angle. So here we need to identify the hypotenuse, opposite, and adjacent. So this is the indicated angle right here. It's not labeled, but there's the indicated angle. And so from the indicated angle to the 90 degree at B, that's our adjacent. So here we have the adjacent. Here we have the hypotenuse, which is always the longest side length. And here we have the opposite. The opposite is always directly across the indicated angle. Now, the sine requires us to have opposite and the, I should not say adjacent. It always requires us to have the opposite and the hypotenuse. Lucky for us, we do. We have the hypotenuse, which is 14, and the opposite, which is 10. Now, keep in mind, the hypotenuse is always bigger than these two numbers. So if this number ever comes up bigger than that, something might be a bit off. So now all we need to do to find the indicated angle is just plug in, go on your calculator, click shift or second. My calculator has a shift button, and then click sine or SIN, and then you just click sine brackets 10 over 14. Sine theta is an unknown number, equals brackets 10 over 14. And now once you have that, you just click equals, plug it in, and it should give you a number 45.5846, yada, 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 but I'll bring that up to 46. So already, if you can see that already, we have the indicated angle found. So we're just gonna label that 46 degrees. Now, what we could do now is we could honestly try and find this missing angle, or we could find this angle here. Now, it's really simple. Once you have one angle found, all you need to do is go 180, because all of these three angles added up is 180. Take away 90, because this is 90 degrees, and then take away 46, which is 44. So right here, it's 44 degrees. Now, in order to find this side length here, there's multiple ways we could do it. We could scrap this and say, hey, this is our angle now. This is the opposite. This is the opposite over here, because this is our new angle. And then we could just plug in 10 times tangent 44. But since I'm demonstrating how to use the sine ratio, I don't think I should do that. So what we're gonna do, we're gonna utilize, I'll just relabel them here. That is bad spelling. So what I'm gonna do is I'm going to use the Pythagorean theorem and say, hey, c squared take away b squared equals a squared. C squared. So basically, 14 squared take away 10 squared will equal this number right here, which is 96. That can't be right. So 14 squared. Yep, nope, I guess so. Yep, so that 96. And now that we have 96, what we want to do is we want to square root it. So 96 square root equals 9.79, yada, 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 which I'll bring that up to a 10. So this equals 10 roughly. Now, to find the sine ratio of A, all we need to know is that this is the opposite and this is the hypotenuse, and that sine is opposite over hypotenuse. So we need to take 10 and then 14, and that's our ratio for sine A. And although it's not always required, you can always divide 10 by 14 and you can get 0.7 with that, and that's also the sine ratio.